This is a picture of the main control box of a machine. The machine has many actuators like motors and pneumatic cylinders. In this video, I'm going to tell you about what is happening in the control box and how the control box operates the machine. I have an experience in mechanical engineering. When I started working in a manufacturing company, I didn't have enough knowledge in the field of electrical engineering, so it often happened to me that I couldn't have good meetings with my coworkers, business partners, and clients. So I made this video for your benefit and for my past self. If you didn't know what a relay and a PLC is, I can show you before you start your career as a mechanical engineer, if you don't have the knowledge about electrical engineering. According to a person who took this picture, this control box is very old. Therefore, it's different from current control boxes nowadays, especially in terms of safety. However, the fundamental control system is not different, so I will explain how the control box works in the order of electric current flows. Firstly, the control box receives electricity at this terminal block. First off, what is a terminal block? It's actually just a simple electric part. Let's take a closer look. This screw is specifically connected with the top cable, as well as the others. I mean, the middle connects with the middle cable, and the last screw connects with the lower cable. Since a power source in a factory has 3 phases, we are supposed to connect 3 cables on the terminal. This terminal block receives the electricity, and then where does the electricity go? This cable is going this way and reaches this electric part. I'll show you my drawing. This is the terminal block and this is called a contactor. A contactor is an electric part that operates a motor, which means that if the contactor turns on, the upper side cables get connected with the bottom side cables. And then, if I turn off the contactor, the connection will open. It's a very simple system, but what turns on and turns off the contactor? How does it work? Let's take our time to know it. I'll be explaining it in my next video. For now, I'd like you to consider a contactor as the same as just a switch. Before moving on to the next electric part, let's know about this switch a little bit more. This electric part is inserted between the contactor and the motor, so I'm gonna draw it. This is called an overload relay. The role is to protect the motor. If excessive electric current flows through the motor, the overload relay turns off the contactor. Would you like to know how the overload relay turns the contactor off? No rush. That's one of the topics of my next video. By the way, we call the system of a contactor and an overload relay together a motor starter. I'm going to put more drawings on the screen, so let me remove some of the drawings you are seeing now. Okay, so I'd like you to look at these. These are actually also motor starters, but unlike this big starter, each of these has a contactor and an overload relay together. I mean, this is a contactor and this is an overload relay. Let me add the drawings of these. Oh yeah, I forgot to tell you. This is for the main motor of this machine. I will write it down. And this is for a motor that pumps lubrication oil. And this is for a motor for hydraulic system. How do you think these are wired? Here it is. If you do the wiring this way, these motors will become independent from each other. But that's beyond our topic. What we'd like to know is how this machine can turn these starters on and off, right? Well, these electric parts will do the trick. These electric parts operate not only these starters, but also operate all the devices in this machine. Do you think these parts are connected with these wires, like these motor starters are connected? Not really. Then, how are they wired? All of these are connected with the three-phase power source, and that means 200 volts is applied to each of them. Your factory may not use 200 volts because it depends on the country where you are. But in this video, we assume that the power source voltage is 200 volts. So let's move on. It's natural to apply high voltage to these motors because the motors need a lot of power. However, these control parts do not need a lot of power, so we should decrease the voltage for them, right? But how can we decrease the voltage? A transformer can do it. So let me illustrate the transformer. How should we wire this transformer? The electric power that these control parts need is not three-phase, but single-phase. So the transformer needs to take in 2 wires from the power source. But don't think that single-phase needs only 1 wire. Single-phase is commonly used in your house, and the outlets in your house have 2 holes for you to insert 2 wires, just like your cell phone charger. The cable has 2 wires inside to let the current of the electricity flow. Don't be worried if you don't understand what I'm saying. I'm going to explain it again soon in this video. Anyways, the transformer needs to take in 2 wires to make the single-phase electric power work. These yellow wires are applied 200 volts, and this electricity goes into the transformer through these 2 wires, because this is just a terminal block. After the transformer decreases this voltage, electricity with a lower voltage comes out from these 2 wires. So, if you connect wires like this, you can use lower voltage. As for this transformer, it can also make these voltages. The voltage of each wire is this, to be precise. If you'd like to charge your cell phone, you will connect the charger this way. If you connect the cell phone charger to only 1 wire like this, the electricity would not flow For a machine to work, you need to make a circuit for the electricity to flow. Do you agree? Let's move on. If you don't charge your cell phone, where do these wires go? The wires go to, for example, push buttons, sensors and limit switches, and also relays, which I'm going to explain in my next video. And of course, the wires go to also these motor starters. You have heard of the word solenoid valve, right? There are exceptions, but this is also connected with these lower voltages. These electric parts can work with these lower voltages because these don't need a lot of power. Before moving on to how these are used in this machine, let's just know about this transformer a little more. These two black wires are the same wires as these yellow wires that have 200 volts, okay? This is just a terminal block, so this 200 volts will directly go into the transformer through these two white wires. And then, after the transformer transforms the 200 volts into 100 volts, the 100 volts comes out from these two white wires. So, we can use the 100 volts if you connect wires like this. These red wires go to these devices. These two red wires are the same wires as these two brown wires. The same thing is happening to these four wires. After the transformer transforms these 200 volts into these kinds of voltages, these lower voltages come out from these wires. These wires have lower voltages, and then you just connect wires like this if you'd like to use the lower voltages. Now, it's time to talk about these parts. This is what we can say the brain of this machine, and this is what we would say nerves of this machine. Your question now is how this machine can operate its actuators, which are like motors and pneumatic cylinders. These parts can do the trick. I will be explaining how these parts work in my next video. We should call it a day. Bye for now.